Alright, is this your card? No? Oh well, let's just do math then. Today we are doing complex numbers, which sounds harder than it actually is. So, some basics of complex numbers. A complex number is a combination of a real number and an imaginary number. And you might be sitting thinking like, okay, this does not sound like it's going to be a fun lesson. Well, okay. Real numbers are things that you've dealt with your entire life. Every number you've ever seen or used is a real number. And that includes decimals, fractions, pi, anything, square roots, whatever. Imaginary numbers, on the other hand, we're going to introduce here today. And the biggest thing really that you see in an imaginary number is that it has an I in it. And we'll explain what that is. Imaginary numbers are what you get when you square root a negative number. Previously, we've always talked about how you can't square root negatives. It doesn't work, okay? That's sort of true, sort of not true, okay? When you square root a negative number, the answer isn't real. There is no real number that times itself makes a negative. So we have imaginary numbers to do that for us. And basic definition here, the square root of -1 is equal to I, where I is the imaginary number. Okay? Using that same kind of idea, I can basically just square both sides then and say that I squared is equal to -1. So, you know, this thing here means this other thing here, basically. Based off of this, that's like your base case example. What I can do then is I can take other normal numbers to square root, like -9. Well, the square root of -9 then would be 3i, because the square root of 9 is 3, and because it's negative, there's an I. That's really what it boils down to. Like here, the square root of 25 is 5, but because it's negative, 25, then it's 5i. Here there's a negative sign in front of the square root, which is why there's a negative sign here in the answer. So again, square root of 4 is just 2, because there's a negative inside of the square root, there's an I, and then also because there's a negative on the outside of the square root, I put a negative out here. So when you put all of this together, what a complex number looks like is these examples here. A combination of a real part and an imaginary part. And these things must be added or subtracted together, where of course these are not like terms. So 5 plus I is a single complex number. -2 plus 3i is a complex number. And then of course these other examples here. But bottom line is, a complex number takes a real part like 4.1 and an imaginary part like 2i and puts them together in one expression, and that one expression, 4.1 minus 2i, is a complex number. So what we're going to be doing for using complex numbers right now is combining like terms, just adding or subtracting them, and that really is just combining like terms. So like right here, 5 and -4 are like terms. So when you combine them, you get 1. And positive 2i and positive 1i, when you combine those, you get positive 3i. And that all worked out because we were just adding. Now if I go in and I subtract here, 7 and 2 are the like terms. However, negative sign, I've got to change this 2 to be a -2. So 7 combined with -2 makes 5. And then likewise over here, -4i and 6i are the like terms, but this negative sign is once again going to change that to a negative. So -4i combined with -6i makes -10i. And so that's just combining like terms, basically. Multiplying complex numbers is just like foiling, exactly using the FOIL process. And there's one little thing that is important to mention, and that is when you multiply two imaginary numbers together, you will get an I squared. Okay, if I take I times I, I'm going to get I squared, and as we saw in the previous slide, I squared is -1. What all that means is in the very last part of the FOIL step. Whenever you do multiply those two imaginary parts together, whatever the sign is, you're just going to change it to be the opposite sign, and you can get rid of the i's, because the I squareds are negative, or make it -1, which just changes the sign, and that's all. But it'll be easier when you see the example. Okay, so here's an example. We're going to multiply this together. So FOIL, 2 times 5 is 10. 2 times -2i is -4i. Just multiplying these numbers together. 3i times 5 is 15, positive 15i. And here we go. Here's that last step I was talking about. 3i times -2i. First of all, positive times negative would be negative. All right? And 3 times 2 is 6. But I've got I times I, which is I squared. Now, because of that I squared, what's actually going to happen here is it's just going to change signs. So rather than being minus 6i squared, we're just going to call it plus 6. Okay? Because the I squared becomes a -1. Let me do this. And so if I change that I squared to a -1, which it is, then here you can see just I've got -6 times -1 became positive 6. And now I'm just going to combine all these like terms here. So 10 and 6 are like terms, making 16. -4i and positive 15i make positive 11i. And so then that would be that answer right there. Another example. 5 times 5 is 25. 5 times -4i is -20i. 4i times 5 is positive 20i. And 4i times -4i is -16i squared. Well, we go in, we combine like terms, and I see that the minus 20i and the plus 20i are going to cancel out. And then, of course, I know that this I squared is really -1, which just changes this to a plus 16. So really, I just have 25 plus 16. 25 plus 16 is, what is that, 41? Okay, there you go. Do one more example. And here, this is just combining like terms, but again, you got to pay attention to the negative sign here. So I need to change these signs. I've got like terms with the 11 and the 1, but because it's minus, it'll be 11 minus 1 is 10, and then with my 5i and my, well, it's -i there, but it's going to change signs to be a positive 1i. So 5i plus 1i is 6i. Okay. So again, the main things we're looking for here is how to combine the like terms and how to FOIL them and how to manipulate these. And also knowing that if you square root a negative number, then it's square root the number like normal, but you're going to put an I at the end of it. And the I squared equals -1. Okay. Go back, rewatch anything that you need to, and I'll see you in class.